With Christmas coming up and the UK coming out of lockdown, I wanted to do something a bit different this year when I see my family, because like most people, I haven't seen them as much throughout the year as I normally would have. When we get together, we always play games, and I usually like to write a quiz, and I was trying to think how I could make that a bit more special, and also solve the issue we have every year of trying to find a balanced quiz that works for people of different ages. I had a think, and I decided on a game show style quiz where people could buzz in to answer questions. There could be a system of earning points and losing points, and possibly the ability to gamble them as well, so that players would just be on a bit more of a level playing field than an ordinary pub quiz. I had the idea in my head to create a system of buzzers connected to a central controller that the quizmaster would use to see who buzzed in first, but also to control who can buzz in for things like head-to-head rounds. I've decided to run the players' buzzers on an Arduino that connects over Wi-Fi to a Raspberry Pi in the quizmaster's controller, and because I want to keep the system as a standalone closed system, I'm going to use the Raspberry Pi to create its own network that the buzzers will be hard-coded to connect to. That way the system can be taken to any location and powered up and just work straight away. I also plan to connect a LiPo battery to the Arduinos to make those devices completely portable. That way they can be used either sat down or at a table or just on your knee on the sofa. To illustrate this, let's say we have 5 clients, red, blue, green, yellow and white, and a controller with 7 buttons, 1 to control each player and 2 to control the game states. When each player powers on, the Arduino will connect to the Raspberry Pi's network and will register itself just to say it's here and it's ready to play, and the controller can then keep track of all the players that are playing. This will be done at the start of the game, and when the quizmaster's ready, the game can then be started. The 5-player buttons on the controller can be used to control who can and can't buzz in, and the quizmaster can then begin the round, and whoever buzzes first will flash on both the correct player and the controller. Once ready, the game can be reset and we repeat. For the game controller software, I'm going to set up a web server on the Raspberry Pi that has an HTTP API that can be used to set and retrieve data about the game. The Arduinos will run in standard C code, the Raspberry Pi will also run a Python script to control its hardware, and I'll also set up an HTML page on the web server to allow a laptop to connect for more detailed information about the game. I also want to be able to set up each player with their own custom buzzer sound, and that'll just be easier to set up on a laptop rather than on the player's buzzer or the quizmaster's controller. For the players buttons, I've picked up 5 of these coloured dome buttons that are about 6 centimetres in diameter. I know that you can buy them on SparkFun and possibly Adafruit, but I picked these up off Amazon and I'm pretty sure they're the same model that they sell. You can get 100mm versions of them as well, but I figured it was unnecessary. That these are big enough that you can give it a good slap, no problem. They have a little nut on the bottom that you take off, and then you can put it through a 24mm hole you've got to drill for it. The only difficulty is because it's got this micro switch in the bottom, you can actually turn this and it'll come out along with the LED as well, and then you can take that off completely and then mount that into your project. It also has this little standoff which I will be using, but I guess you don't have to if you wanted to mount it flush with a panel or something. I guess you could do that as well, but for what we're doing, we don't need to do that. The micro switch itself actually has an LED holder in it, similar to a Christmas light style, so you can actually just pull that out. And then on top of that is an LED with an integrated resistor. You can see it if you look down into that tube, you can see that there's a resistor. And I think it's a 470 ohm resistor, which is too big if you're running off a 3.3 volt supply. So what we're going to do is we're going to unwind that LED from these little tabs on the bottom, take the LED out, unsolder the 470 ohm resistor and put in either a 220 ohm or a 330 ohm depending on, I don't know. We're going to put a different resistor on it basically, so that we can run it on a 3.3 volt system, and then we can just pop that back on. And then when you're ready, you then put it back in. There's 2 notches on the bottom that you can see, and you can see it slides on, and then you just turn and click and it fits back on as well. The first time you do it, it's a bit of a twist, so be careful. I didn't want to do it because I thought I was going to break the entire thing, but it's not. It can be a bit stiff on that first time. So with that in mind, let's take I've got 5 of these, so let's go and replace all the resistors, sort the LEDs out, and then I'm going to solder directly onto the tabs. I'm not going to use spade terminals because I just don't have any and I can't be bothered, and it's going to fit inside a housing, so it doesn't really matter anyway. controller, I'm going to be using these clear arcade buttons. These came from Pimoroni as part of their Picade plasma upgrade kit, which takes the normal opaque arcade buttons on their Picade system and adds these clear RGB ones. The actual button itself is just clear, and then it mounts onto one of these plasma boards on the back, which has four addressable RGB LEDs, which you can then obviously change the color of. So I'm going to mount 5 of those on the top of a box, and then that'll give me control of each client and light them up as each of those clients connect in the correct color. So obviously I've got 5 dome colors in red, blue, green, yellow and white, and then I can have 5 of these, again light them up depending on whether or not they're connected, and then I'm going to add another 2 in just for some basic game controls, things like starting rounds, resetting buzzers, that kind of thing, and all of that is going to run off a inside the box. I'm also going to mount a Raspberry Pi, and then on top of that I'm going to put this Picade hat. So this is actually the controller used again inside the Pimoroni Picade system. So it has the ability to connect all the buttons up. The lights, which are going to run over, like I say, they're going to be plasma lights, so they're actually daisy chained, which makes those quite easy to wire up. And this also has scope for a speaker, which I'm going to use, and a joystick, which I'm not going to use. And then things like a power button for the Raspberry Pi on the side, so that I don't have to just rely on plugging it in and then letting it power up, and then as soon as I unplug it, do that. At least I can have an actual power switch on it. And that'll be quite nice, just to keep all the wiring nice and simple. So that's going to go in the box as well. And let's go and drill a load of holes, mount all those things in, and then see how it turns out. Final things I did to the Quizmaster's controller, which I didn't show you on camera because it was either too boring to watch or because I was still waiting on parts and I just didn't film it because it was taking a little bit too long, was first I reinforced the back of where the switches are. So there's a bit of 3mm acrylic there which I had laser cut out, just because you saw it in the video just when I finished it off that as you were pushing down on those buttons it was quite flimsy, so that bit of acrylic has really helped reinforce that so that it's not quite as flimsy anymore. And you can also see here where I've wired up all the buttons. So the red wires are the daisy chained LEDs. They start over here on the right hand side, which goes directly from a header on the board, and then each of the 7 buttons is all wired up directly onto the Picade's inputs there. You can also see the power switch here, where this has got a built-in LED on it as well, so it shows the power status. And again, that goes to a header on the Picade hat, so that it has all that functionality on top of it. And then the final things that I did were I added a power switch and a USB-C input, and you can see that those are wired up on the inside there, just about. So that's quite a cool panel mount USB-C thing that I found on Amazon, but I think it's used in cars or boats or something, but it's basically just a panel mounted USB-C socket that goes to a USB-C cable. I've just spliced into it here so that I could attach a power switch to the 5-volt rail, but otherwise it's quite nifty to be able to have that in. And that is everything, which leaves our which leaves our controller all finished. So let's get this screwed back in, and then I can move on to making all the players. I had a bit of difficulty when it came to the players' buzzers, because it turns out the boxes that I had originally ordered for them weren't actually deep enough for the Switch and the Arduino and everything that needed to go inside. It turns out I'd measured from the underside of the Switch to the bottom of the thread, but I'd completely forgotten that there was a switch that you have to click into the bottom, which we saw before on the video. And in order to order new boxes, I wanted to make sure that I didn't get something that was super deep that would then have the Arduino mounted underneath it. So I ended up going for one with a larger length, which allowed me to put that Arduino then on the side without compromising the depth of the box. And the box that I chose in the end actually turned out to be quite a nice size, like I say, for putting it on top of a tabletop or just resting it on your knee or whatever. And the other nice thing was the injection point for the plastic of the box was directly in the middle on the bottom, so I didn't have to measure out where to drill the hole or anything, so that was quite nice. Just had the final components of the system arrived. The last thing I was waiting for were the batteries that are going to go inside the players' buzzers. So that is the package that has just arrived. And I've actually got a battery as well for the Raspberry Pi, which I don't plan on putting in straight away, but I have got one just in case I decide. So although the controller at the minute can only work if it's plugged in, by adding that battery in, it'll be the same deal as It'll be the same deal as the players' buzzers, that it can be just used whenever, as long as it's charged up. So here we go. These are 1.2 amp hour batteries from Pimoroni. And there you go. So the intention is I'll just put some double-sided tape on the back of those, and then I'm just going to plug that directly into the side of the Arduino, which conveniently already has a voltage regulator and a power switcher, if you like, and a battery charger all on board. So as long as that's plugged in, if it's plugged in by USB, it'll power the Arduino and charge the battery, and then as soon as you unplug it, it'll just charge the battery. So yeah, just to give you a quick look at the Raspberry Pi battery I've got as well. I've also had to get a board for this because the Raspberry Pi obviously doesn't have a battery charger built in like the Arduinos do. And there are a few different options out there. There are LiPo shims that you can get for these batteries, which basically allow you to... Oh, some noisy. There we go. So there's a LiPo shim you can get for the Raspberry Pi that lets you power it from a rechargeable battery, but it doesn't have a battery charger on it, which is kind of annoying. So I instead bought this Adafruit Power Boost board, which does have a battery charger on it and does all the stuff that the Arduino does, between like switching power between the battery and the USB port, depending on which one's present. And yeah, that's quite nice. That's got a little pass-through, so it can connect to micro USB there, and then output to a USB-A, so it can act as an in-between board, if you like. But it's not part of my plan at the minute, so I'm just going to keep it for later on. And then the battery I got, because it was on a Black Friday sale and it wasn't that much, there wasn't a massive difference in price between each one, is this ginormous 8.8 amp hour rechargeable battery. This is a lithium ion, not lithium polymer battery, but it is, yeah, that is a really beastly battery that should be able to handle a couple of hours of Raspberry Pi usage. But like I said, I'm not going to pop that in just yet. For now, we're going to get the batteries inside the players' buzzers, and then that will be all the hardware done, and then it's onto the software. I skipped ahead a little bit on the build process on these, just because I didn't want to make the video too boring. But I've added feet onto the underside, which you may have seen on the underside of the Quizmaster's controller as well. And then if I just show you inside... There you go, so you can see here where I've wired it up, and I've soldered directly onto the underside of the Arduino and just snipped all the legs off. So this is what I was referring to before when I said that instead of having the Arduino directly underneath the switch, I've actually had it offset, so it just about fits there, and so it clips in quite nicely like that, which worked out alright. And then when it comes to taking it off, I can then just untwist that and take it all apart, and then finally just unplug the USB port. So just like on the Quizmaster's controller, I've got this is a micro USB because that's what's inside the Arduino, and again, I think that's made for boats or cars or something. And I have a switch in there already, but it's actually going to be going to the rechargeable battery rather than directly onto this, because this is only really going to be used to charge that battery. So once it's unplugged, it'll be solely down to the switch turning on and off to decide if the Arduino is being supplied power from the battery, just to make sure we can turn it off and obviously not drain that battery down. I also, in the end, I did need spade terminals. If you recall, I soldered onto those spade terminals, so I didn't have any. And I didn't want to solder onto these because it meant that I could remove the switch. And obviously it doesn't matter so much on that because I can still remove it with or without spade terminals, so I did end up buying some in the end. You can see there the Arduino is attached just on the metal standoffs there. I think they're like 8mm or 9mm or something. And then there's the rechargeable battery port just poking out the side. So if we get our rechargeable battery and just plug that into here, and you can't really see it, but there you go. And with that, I've now completed all the hardware for the project. I've got the Quizmaster's controller box all done, and I've also got the 5-player buzzer boxes all ready for programming. I'm going to go away and program them up, and then in the next video I'm going to give you a showcase of everything all working and a little run through of how the software ran, so make sure you subscribe so you don't miss out on that. Leave a like if you like the video, leave a comment down below, and I'll see you in the next one.